Oh, welcome back and thank you for joining. Let's continue with some examples of derivatives of reciprocal trig ratios. Recall that the derivatives of reciprocals are cosecant x has a derivative equal to the function itself times cotan, and whenever we differentiate trig terms with a co as a prefix, then the derivatives will have a negative sign. The second derivative is derivative of secant that equals the secant itself multiplied by tan x, and the last reciprocal is the derivative of cotan, which is negative cosecant squared x. Let's start with our first example, number 1a. Whenever I differentiate a trig function, or any function for that matter, I try to create an idea or to map out the equation. I want to check and see how many terms I have and how they're connected to each other so that I can select the correct strategy to differentiate it. So in this case, we have two groups of terms separated by a minus, which means that each group will be differentiated separately because the derivative of the sum or difference is equal to the sum or difference of their derivatives. So we'll start off with g of x, so g prime would be equal to. Now, once we have figured out how we are differentiating each group of terms, then we have to analyze each term to check and see if we have any chains. So in the first term here, 3 secant x, there are no chains. We just have a coefficient of 3, which will sit there quietly, and then we'll differentiate just secant of x, and derivative of secant is equal to the function itself multiplied by the tan. Now we continue with the next term. So again, a coefficient of 10. Derivative of cotan is cosecant squared x. And don't forget, whenever we differentiate a trig term with a prefix co, then the derivative will have a negative sign. So simplify. We have 3 secant x, 10x, and then plus 10 cosecant squared x. So we'll leave this derivative in this form, and we'll move on to the next example. Now here we have gx equals 2 cosecant 3x plus cotan of 5x. Again, I want to check and see how many groups of terms I have, so this will be differentiated independently of the other term because they're separated by a plus. Now let's examine the first term. So cosecant of 3x, I notice that here we have a small little chain. So we have the cosecant, which is the outside function, and the 3x, which is the inside function. We have a coefficient of 2, so we don't have to do anything about that. So 2 will sit right here. We'll differentiate the outside function, which is cosecant. So for cosecant, we know that the derivative of it will be cosecant times tan. Now, the inside function will stay the same, so it doesn't change, and that is because we are differentiating just the cosecant. And then we multiply by the derivative of the inside function, which is simply 3. Now, if it makes you feel more comfortable, you want to put these in brackets just so that we won't confuse number 3 being inside the 3x. And then we continue with the next term, which is cotan of 5x. So again, here we have another chain. So we have cotan as outside function and 5x as the inside function. So the derivative of cotan, remember, the derivative of anything that starts with a co will be negative. And we know is cosecant squared, and inside obviously is not changing. And then we take care of the inside function, which is 5x, and the derivative of it is 5. So next we want to simplify this expression, write it as neatly as possible as well. So 2 and 3, the monomials, will come together. 2 times 3 is 6. And then we have cosecant of 3x, tan of 3x. And then plus and minus will make a negative. It is best to write the monomials before the trig term, so negative, and then we have 5 cosecant squared 5x. As a last step, we check and see if we can factor, so take out the greatest common factor. And you probably notice we have cosecant in both terms. However, we cannot factor out cosecant, and that is because they represent the cosecant of different angles, so they are not like terms. Let's continue with our example number 2. So in this example, we have f of x equals the square root of secant power 3, and then the fourth root of x is the angle. So a couple of things we need to do here. First of all, we want to convert all the radicals into powers, and that is because it makes it easier for us to see how to use the power rule to differentiate. And secondly, we have to identify the chains. So I will be rewriting this function. So again, we're not differentiating yet, we're just simplifying the function. And as I rewrite it in power form, I also try to identify the chains. So the very outside chain will be the power of 1 over 2, which corresponds to this square root in here. Now, the next chain that we notice is the power of 3. So we have a power of 3, and the power of 3 is applied to secant. So secant is brought to the power of 3, and inside we have the x to the power of 1/4. So let's check and see if there is anything else we can do to simplify this function. As you can see here, we have the secant ratio brought to the power of 3, and then the entire thing to the power of 1/2, which means that we can easily apply the power rule in here and bring these two together to reduce the number of chains in the term. Now, in case you were thinking whether or not we can also combine with power 1 over 4, please keep in mind that power 1 over 4 here is applied to the angle, which is an inside function. And here, power of 3 is to the secant, and power of 1 over 2 is applied to the power of a secant. So yes, these two can be combined, but 1 over 4 cannot join the party. So let's simplify the function a little bit more. So f of x equals, so we have the secant of x to the power of 1 over 4, and then the entire thing will be to the power of 3 over 2. Now let's re-identify the chains here in the simplified form of the function. So I'm going to make this a little thicker so we can see it better. Here we go. So we have the outside function, which is a power of 3 over 2. And we have the inside function, so the first layer, which is the secant. And then we have a third layer here in the chain, or the third chain, which is the x, the angle x to the power 1 over 4. Now we can start differentiating with confidence. So we have f prime of x equals, we'll start off with a red chain. So we have 3 over 2 becoming a coefficient, and the power here will become 3 over 2, take away 1. Now, what's inside that chain won't change, so this will stay secant of x to the power of 1 over 4. Next, we are differentiating the secant, which is the second chain. Remember that the derivative of secant is secant multiplied by 10. So the function itself multiplied by the 10. Again, remember that the angle is not changing in this chain. Let's make them completely blue, including the brackets in it. Now, once we have differentiating the second chain, we are going to look into the inside, the very inside of this function, which is x to the power 1 over 4. So the derivative of x to the 1 over 4 is 1/4 x to the power of 1 over 4 minus 1, just the power rule. So let's see what we have created in here. I'm going to have to make this a tiny bit smaller, sorry. Here we go. Okay, so now let's simplify this. We have f prime of x equals, so notice that here we have a monomial 3 over 2, and then here we have a monomial of 1 over 4, so these can come together. So 3 over 2 times 1 over 4 will make 3 over 8. And then we have the secant of x to the power of 1/4, all of it to the power of 3/2 minus 2/2 would be equal to 1/2. And then multiplied by secant of x to the power of 1/4 multiplied by tan of x to the power 1/4. And then we have 1/4 minus 1, so minus 4/4, which is basically negative 3/4. So we have x to the power of negative 3/4. Remember that we have taken out the 1/4, or 1/4 has joined 3/2 here. So as you can see here, there are terms that we can bring together. So we have secant of x to the power 1/4 power 1/2, and secant x to the power 1/4 again here, but to the power of 1. So as you can see, the insides or the bases here are exactly the same, which means that we can bring them together inside the same power. So one last step. And we have the derivative f prime of x equals, I'm going to draw a big fraction line in here. We have the number 3 in the numerator, 8 in the denominator. This negative power here can come down to the denominator, x to the power of 3/4. The secant of x to the power 1/4 will join each other. So x to the power 1/4 to the power of x to the power 1/4 to the power of 1 plus 1/2, 1.5, or 3/2. And then tan of x to the power of 1/4. And this would be the more simplified form, or the most simplified form of this derivative. Just going to be consistent here with all the colors. Okay. And there you go, voila. Now, let's continue with the next example. Here again, we have a function that is given as difference of two groups of terms. So we differentiate each group separately. So we have h prime of x equals, so the first is just a polynomial term. So you apply the power rule. So 3 times 5, 15, x to the power of 4 minus. Now in the next group of terms, we have the product of two different terms, and they belong to two different groups of functions. So we have x squared, which is a polynomial term, and cotan, which is a trig term. So we're going to leave that minus outside the brackets here, because you know that we are differentiating the product here, which means we're going to get two groups of terms. So take the derivative of x squared, which is 2x, multiplied by the other factor, cotan x. And now we add the derivative of cotan, which is cosecant squared x, but with a minus, because you know the cos, coco minus. And now we have the other factor, x squared, which is multiplying this. So let's see what we get in a more simplified form. Again, the first term would be 15x to the negative 4. And I would try to actually simplify the insides first. So 2x cotan x, and a plus and a minus will make a minus. I would prefer that we write the term x squared before cosecant, so to avoid any confusions about whether or not these two belong together. They don't, right? And then close the brackets and check and see if we have any common factors. It seems that we do. It's not a very big common factor, but there is one. So we have 15x to the 4 minus 2x cotan x, and then plus x squared cosecant squared x. So we can take out x, and the factored most simplified form will turn into 15x to the power of 3 minus 2 cotan x, and then plus x cosecant squared x. And that would be the answer, or the derivative of h of x. So thank you for learning with me, and I'll continue with the next part of the lesson in the next video. Bye for now.